Good morning, students. Let us now start with the next unit of the 11th class, that is Redox Reaction. It is our 8th unit. Lecture number 1. First question in this unit is discuss classical concept of oxidation and reduction. So according to classical concept of oxidation and reduction, oxidation is the process involves the addition of oxygen or some electronegative element. For example, C plus O2, oxygen is added to carbon, this is oxidation. Then we have 2FeCl2 combines with Cl2 to give you 2FeCl3. Electronegative element chlorine is added, so this reaction is called as oxidation. Oxidation is also defined as the removal of hydrogen from a substance, that is also called as oxidation. Then we have the oxidizing agent, the substance which bring about the oxidation, it is called as oxidizing agent. The substance which brings oxidation is called as oxidizing agent. They are in the above cases, it is oxygen and Cl2, they are called as oxidizing agent since they are bringing oxidation of carbon and FeCl2. Then we have the reduction, addition of hydrogen. It involves addition of hydrogen or some other electropositive element. For example, N2 plus 3H2, this is reduction to NH3. CH3, 4, CH3Cl given hydrogen. In the presence of nickel, it will be CH4 plus HCl. So this reaction is called as reduction. The substance which is adding hydrogen, it will be called as reducing agent. So now what is reducing agent? The substance which is adding hydrogen or electropositive metal, electropositive element is called reducing agent. And the substance after gaining oxygen, it is said to be oxidized. The substance after gaining hydrogen, it is said to be reduced. So we have the 6 definition. We have oxidation, we have reduction, we have reducing agent, we have oxidizing agent, then oxidized substance and reduced substance. So these are the some definitions. Then we have the why question, why oxidation and reduction they occur simultaneously. This is question number 2. Why oxidation and reduction occur simultaneously. Oxidation and reduction, they go hand in hand, they occur simultaneously because whenever a substance supplies oxygen, then there must be a substance to accept that oxygen. Similarly, if a substance supplies hydrogen, there must be another substance to accept that hydrogen. So oxidation and reduction, they cannot be separated from each other. Both of them, they are taking place in the same, under the similar conditions, under the same reaction. Let us demonstrate it by an example. Zinc oxide reacts with carbon to give you Zn plus CO. Zinc oxide is supplying oxygen, so it is oxidizing agent. Carbon is taking oxygen, it is reducing agent. Zinc oxide to zinc, when you go, it is said to be reduced, lost oxygen, and carbon to CO, it is said to be oxidized. This process from here, zinc oxide to Zn, this is called as the reduction. And carbon to carbon oxide, it is carbon monoxide, it is called as oxidation. So all of the six phenomenon, they are taking place in the same reaction. So this is the classical concept of the oxidation and reduction, and we discuss why oxidation and reduction, they occur simultaneously, since they, whenever a substance supplies oxygen, there must be a substance to gain that oxygen. It means they will go hand in hand. One cannot separate oxidation from the reaction. If there is some donor, acceptor should be there, only then it is said to be the donation. If I lost my wallet or I lost some money and I say I have donated that money, that is wrong. I have not donated, but that money has been lost. Now we discuss the second concept, that is called as electronic concept of oxidation. Discuss electronic concept of oxidation and reduction. So we must keep in mind oxidation, it involves loss of electrons, and reduction, it involves gain of electrons. Oxidizing agent, which gains electron. Reducing agent, the substance which supplies electron. Oxidized substance, it is the reducing agent which supplies electron. The reduced substance, it is the oxidizing agent which gains electron. Let us demonstrate this reaction. Zinc combined with copper 2 positive ion to give you zinc 2 positive plus copper. This is said to be oxidized. It has lost electron and called as reducing agent. This is the oxidizing agent gaining electron. From here to here, this is the process of reduction. From zinc to Zn2 positive ion, this is the process of oxidation. Zinc after losing electron is oxidized, copper after gaining electron, it is said to be reduced. So this is our electronic concept of the oxidation and reduction. We can have another reaction where copper supplies electron to silver positive ions and changes into Cu2 positive and 2 Ag. You are asked to identify oxidizing agent, reducing agent. So this is our reducing agent here, oxidizing here. This is said to be oxidized. Charge has been generated. Charge is lost, therefore it is reduced. From silver to silver, it is called as reduction. Copper to copper 2 positive ion, it is called as oxidation. So this is regarding the electronic concept of oxidation. Then we come to another question. What are redox reactions? This will be question number 3. What are reactions. Discuss their types. Redox. This term is made of two words, red plus ox, because these reactions involve both reduction as well as oxidation. They are called as redox reactions. So redox reactions are those which involve reduction as well as oxidation. There are two types. Number one is direct redox reaction, or those reactions where oxidizing and reducing agents, they are in direct contact with each other. The flow of electrons, they takes place over a very small distance, and energy, the kinetic energy of the electron, that is lost in the solution. Therefore, this solution gets heated up during the redox reaction. For example, when zinc rod dipped in blue colored copper sulfate solution, when blue color of the copper sulfate disappears, it is due to direct redox reaction between zinc and copper ions. We have copper sulfate solution. Zinc loses electron and changes into ionic form, and copper gets deposited at the bottom. So this is our redox reaction direct. And this reaction is accompanied by evolution of heat, where heat is produced during the direct redox reaction. So why heat is produced in direct redox reaction? The reason for that is the flow of electron that takes place over a very small distance. Therefore, the energy of the electron, which is called as kinetic energy, that has not been utilized in doing work. If they would have moved from one position to another position, then energy would have been utilized. Since they have not worked, the transfer has taken place over a very small distance. So that energy is lost in the solution, and solution gets heated up. So these are called as the direct redox reactions. Then we have second type, indirect redox reactions. These are those reactions where oxidizing and reducing agent, they are not in direct contact with each other. Oxidizing and reducing agent, they are not in direct contact with each other, and the flow of electrons that takes place over a large distance. So the kinetic energy of the electron, that is not lost in the solution, and solution does not get heated up during this course. So kinetic energy of the electron, that is used up in doing work against the metallic kernel or metallic bond, the force which was operating between mobile electrons and the metallic kernel. That's why no heat is produced during the indirect redox reaction, and these reactions are carried out in the electrochemical cell. So electrochemical cell, these are the devices which convert chemical energy of the electrolyte into the electrical energy. An electrochemical cell consists of two halves. For first half is zinc rod. If they are in 1 molar solution, this is called as oxidation half cell. Then second half cell, it is also having a salt bridge, a U-type tube filled with agar-agar plus KNO3. This is second half. This is copper rod dipped in 1 molar copper sulfate solution. This is called as reduction half cell. Now what is the reaction taking place in the first half cell? Zinc loses electron. This reaction is called as oxidation half reaction. Then these electrons, they move through the wire and they come to this rod where they are accepted by the copper ions, whose standard reduction potential is very high. Now both of these reactions, they are added together. We got redox reaction of this electrochemical cell, and a cell voltage of 1.10 volt was seen in this case. So this is your indirect redox reaction, where oxidizing and reducing agent, they are not in contact with each other, and the flow of electron that takes place over a larger distance than their ionic diaphragm, ionic sizes. So these reactions, they are called as indirect redox reactions, and they are accompanied by liberation of electric current. They are not accompanied by liberation of heat in this reaction. Now how will you justify oxidizing reducing agent in some of the reactions? CuO combines with H2, giving you Cu plus H2O. So in this case, CuO is oxidizing agent, this is reducing agent, this is said to be reduced, this is oxidized. Now from here to here, oxygen is lost by this. So this reaction is called as oxidation. Reduction. This is called as oxidation. Then we have another reaction, Fe2O3 combining with 3CO give you 2Fe plus 3CO2. It is supplying oxygen, oxidizing agent. This is reducing agent. This is reduced. This is oxidized. Then we have few more reaction, 4NH3 plus 5O2. We get 4NO plus 6H2. This reaction, this is called as oxidizing agent, this is reducing agent. This is said to be oxidized. Oxygen is taken here, here hydrogen is reduced. So in this manner we have to identify the oxidizing agent, reducing agent, oxidation, reduction, oxidized substance and reduced substance during the redox reactions. So up to now we have discussed two concepts of the oxidation and reduction. Along with that, we have discussed redox reaction and their types, and we have identified some of the reactions as oxidizing agent and reducing agent. Next concept, third concept, that will be taken in the next video.